Assalamu alaikum everybody. This is me Khalil Houthi. In this video, try to help you or guide you with the last exercise I gave to you about 2 weeks ago, and the submission is due on Wednesday next week. Uh, so I will go question by question. I probably will make two different videos. I don't want the videos to be very long, so it will take a long time to upload them. For the first video, will answer or guide you on solving question 1 and question 2. These are simple questions. The next video, I will show you how to solve for question 3. So let's go one by one. In question 1, it says whenever there is a vertical force and some horizontal forces, we assume in this case the horizontal force in the x and y direction are the same. Usually the x-axis we donate it as sigma 2, whereas y-axis, force from the y-axis, we donate it as sigma 3. If the forces, horizontal forces, are equal, sigma 1 and sigma 2, they're gonna be equal. The vertical force is sigma 1. Most often it's donated as sigma 1. So what are the values of these forces? We have sigma 1 as 500 and sigma 3 as 300. And we need to plot them on a Mohr circle, what we call a Mohr circle. It's a circle defined by a radius and a center point. X value of the center point and Y value of the center points. You go back to the PowerPoint slide I sent you. So this is the angle of the fracture. What are they? This is the angle. In this case, the angle is the flat lying fracture. So the angle is 0. The angle is 90, and finally the angle here is 45. If we assume that this is a fault plane. Whenever you exert a force on anything, there is a preferable direction of fracture or break. In geology, we name that plane either a fault plane or a fracture plane. So in these three cases, the same force is applied in different rock sample. One of them, rock case A, was fractured horizontally. That's the angle. It's 0. Angle is 90. And finally, angle is 45. To draw a circle, we need to go to the equation of Mohr circle. That's the final equation of Mohr circle. It's simplified as such. That's the general equation of a circle. The circle has an x radius, y radius, and x-axis, center point at x-axis, center point at y-axis, and a radius. So radius equals what? Sigma 1 minus, that's in our case, sigma 3 divided by 2 gives you the radius. Uh, the y, if I equate this part with this shear stress squared, um, there is no center point, or the center point at y-axis is 0, always. Whereas the center point at x-axis is the value you see here, sigma 1 plus sigma 2 divided by 2. So let's plot based on these things. Let's get this. What's the x-axis value? The y-axis value is 0. And what's the radius of the circle? And we can plot it. To plot it, you need a graph paper. So I'm not able to. I make a video on capturing a graph. So I went and found some online application. This is an online application. We use this application to draw circles. Before that, I want to do some math calculator, and I I don't like to use the normal calculator here. I prefer usually to use Google Colab or Python because I see my outputs, I remember my outputs, I repeat things quickly. So don't install anything. Just go to Google Colab, type in search bar Google Colab or Google Collaboratory. Make sure that you are logged in Chrome using your Google account, SKU Google account or SKU account, which is a G Suite email address. Log into Chrome using this your own SKU account and search for Google Colab. So the first results or the first output you get from your search, choose it. Welcome to Collaboratory. Click on it. It will soon take you to Google Colab. That's Google Colab. These are the recent notebooks I was working with. I can close and I go back then to file new notebook. It's an empty new notebook. I open a notebook. In this notebook, I try to make simple calculation, which is like 500 plus 100 divided by 2, things like that. So to do math things, you need to import a function or a library called math. Import math. So that's the math library. I just click on Shift and Enter or Control and Enter or Alt and Enter in your keyboard. So I got this one. I give two variables. I have two variables, sigma 1 equal 500. From where 500? That's the value I'm given here. And sigma 3 is 100. Let's draw the Mohr circle. So from these two, I want to get the radius and the centers, x-axis centers, 100. So radius is equal to how much? If we go back to the PowerPoint, the radius is that value or this thing, the whole term, sigma 1 minus sigma 3 divided by 2. So it's sigma 1 minus sigma 3 divided by 2. I calculated, let's see what is the radius. That's the radius. What's the value of the radius? It's by default is 200. Let's calculate the x-axis. The x-axis can be calculated in such a way. Instead of minus, it's a plus. If you go back to the PowerPoint, sigma 1 plus sigma 2 divided by 2, it will give you the h. The k is 0. So here this is center x and center y is basically 0. So center underscore y equal 0. Center underscore x is that value, whereas center underscore y is 0. So let's see what's that one. My perception says it's 300. Simple calculation. 500 plus 100 divided by 2, 300. So if I go back to my graph paper here, I can zoom in, zoom out. So let's zoom in a bit. This is 300. That's x-axis is 300. Y-axis, which is the shear stress. This is the normal stress according to the equation of the circle. This is the normal stress. That's the equation of this is the x-axis is the normal stress. The y-axis is the shear stress. So I have the center point, which is 300 and 0. So let's make a circle. How to make in this toolbar, you'll find this function available as you see here. So I need a circle with a center and radius. So there is a pop-up window below. It says that make a circle using radius, center, and radius. That's the thing we click, and I can click anywhere. The radius was 200. Back my that was the radius, and the center x-axis is 300. Y-axis is 0. Okay, so there is something wrong. So the center point should be 300 and 0. Click OK, it moves. So this is the circle. Circle is defined as a point, which is A, and a radius. A point, a point in this system, Cartesian system. So I don't want, if you don't want to see A plotted here, you just replace A in here with its value. Its value is what? 300 and 0. Enter and delete. Then you can delete A. If you right away delete A, the circle will be deleted too, because circle depend on A. The circle have a variable A. It will be deleted unless if you give the variable, sorry, the values of the variable. So I can delete it. How I delete something? I click on these vertical three dots and I choose from drop down menu. I choose delete. Here is a circle having, I go back here. Make sure that you are always in moving mode. So if you click accidentally in here, multiple cycles will be generated because you are in this, you clicked already in this mode. If I click right away, you'll find that more and more circles are generated. Actually, if you make a mistake, you can click Control Z. So this is my circle. Right now, I need to draw the points or the rock samples A, B, C, where they will be drawn here. The forces are not changed. The orientation of the fracture is changed for the three cases. So I should work out how to get A, B, and C, where they will be plotted on this circle. All the fractures, when there is a fracture, they will be drawn on the circumference of the Mohr circle. If I go back, I need to find where it will be drawn actually on the circumference of the Mohr circle, but exactly where, here, or where exactly. This can be done if we know the X and Y points. To know the X point, what you do, you go back here. So what are we given? The angle in case A is how much? Is 0. Flatly lying fracture, it's 0. And we already know sigma 1 and sigma 3. So can we work out? Yes, this is the X point. And we also need the Y point. Y point can be worked out using the shear stress. This is normal stress and this is shear stress. Normal stress is the x-axis, whereas shear stress is the y-axis. By the way, let's put them in here. So let's label the axes. I can go here, click and text. Let's name it normal force, normal stress. It's not force, it's stress. And let's name this one shear stress. Oh, I need to change this one. It's a text. Normal stress. Yeah. You want to see them? Click on this one. That's the normal stress. You bring it here. This is the highlighted here. This is the shear stress. It looks a bit ugly because why in here, if you go back to the PowerPoint, we see sigma normal and this thing. I'm not sure what they call it. That's sigma. This is rho, probably. I'm not sure what value is that, what they name it anyway. It's a shear stress. Well, I can search it in Google to see what is it, but it's better to draw them as shown there. So for the normal stress, that's the normal stress. Let's click on it first and right click here, setting, go to text. Let's use a latex formula. So it becomes like that. I say it's a latex formula. So then I can use latex equations, sigma underscore uh, normal, I think. Sigma underscore normal. So that's it. That's it. I click OK. That's fine. Let's do the same for the other one. For shear stress, setting, text. It's a latex formula, and let's use sigma underscore mu, probably. I name it mu. Sigma. Oh, sorry, mu. We need this backslash to define any such samples. Sigma mu. So if you search, for example, latex samples, um, you'll find them here. There are so many samples. I'm not sure what was that sample we have seen. It's yeah, I think it's there. Sigma tau. Yeah, that's tau. So let's change this one to tau the same way we see it. Where is my? Here is it. Let's make it tau. Yeah, or simply tau. That's the one. This is tau. Is sigma underscore n. Normal force. That's shear force. That's some. If you want to choose another, that's sigma capital, sigma small, and so on. There are many latex samples. So we defined our Mohr circle. Let's plot those different rock samples A, B, and C. I go back here and use the equations I'm provided with. Uh, for x-axis, I use this one. For y-axis, I use this one. So in here, let's create a function. I'm not sure whether you are aware of functions, but if you don't want to use Python, you are then allowed to use your own calculator. Define traces, name it, any name I can give. It needs two values, sigma 1 and sigma 3, uh, and we need to calculate normal stress. The normal stress is how much? Let me do this thing. This is the PowerPoint. Normal stress is simply you open a bracket. I get my sigma 1 plus sigma 3. That's sigma 3 from here, divided by 2 plus sigma 1 minus sigma 3, whole of this one, let's make it inside brackets, multiplied by. So from where I can get cos, math helps you. That's the reason we needed math. So it's cos 2 theta. I also need theta, another parameter in this function. So I say math dot cos. So if you put your mouse here for a while, it retains the cosine of x measured in radian. measured in radian, but we provide them in degrees. So let's convert cos 2 times the angle. What's the angle? The angle is in degrees, but this function accepts cos here, accepts the values in radian. To convert, you do that. Math radians. So you see, if you hover your mouse, keep it a while, it tells you what this function does. Converts angle x from degrees to radians. We need to convert them to radians because the function itself reads values in radians. 2 times cos 2 times cos theta again based on the equation we see 2 theta. That's how is it? That's what this is normal force, and we need also shear force. Shear stress. It's not shear force, and the shear stress is that value sigma 1 minus sigma 2 divided by 2 multiplied by sine 2 theta. So it's basically this thing you see here. It's almost this one. There is only one difference. Instead of cos, we use sine. Instead of cos, we use actually sine. And we ask the function return those two variables I just created, shear and normal stresses. And I can reuse this equation again and again and again. So I inserted sigma 1, sigma 3, and theta. I need 2 points in this coordinate system to put a point. The point is either A, B, and C. So I run it. This is my function. It's created. So let me create here a text. I name it or fracture or case A. In case A, the theta, the angle or the fracture is horizontal. It's 0. So stress is my function. I give the value. Sigma 1 is 500. Sigma 1 is 300. And finally, theta is 0. So let's see what it gives me. Uh, one argument, radians. Sorry, I forgot to put the radians in here. That's the angle. That's theta. I haven't provided any angle. That's theta. This is theta. This is a mistake from my side. Um, See, everything is okay. Yeah, everything is perfect. So yeah, I need to put an angle. I haven't provided the angle value. It's so case A will be at x-axis 500, y-axis 0. Let's try to plot it. I go here, point, it's a point, and just plot it here. So it's A having x-axis 0, y-axis x-axis 500, y-axis 0. And if I want to change its name, I go to setting. Instead of A, I name it A small. That's it. That's for case A. Let's do the same for case B. That's make a text here. That's case B. In case B, the theta is not 0, is 90. The forces haven't changed. If the forces changed, you need to draw another Mohr. So they're going to be a different Mohr. It's not 900, it's 90. So let's see where it will lie down. This point B, or fracture having orientation 90. So the the x-axis is 100, whereas the what value is that? Ah, it's it's very small value. It's almost zero. It's zero. It's something raised to power minus 14. You might ask why it's not zero, because computer is not, they cannot work precisely. There is no computer can work can give you floating numbers precisely. That's the reason. What are floating pointers? Why there is those errors? You don't need to know. But basically, this is zero. Nothing compared to value you see here. 100 and something raised to power minus zero. It's 1 divided by uh, 1 times 10 raised to power 11. It's very small number. So it's 100 and 0. 100 and 0. Where I can plot it. That's 100. That's the x-axis 100. Y-axis is 0. So this point will be drawn here. This is that's the new point. It's 100 0. Let's change its name. Setting name it B. I changed the name and named it B. And finally, let's work out the last part, which is C. Okay, C. Let's make it capital. And I get the same function. That's my function. I call my function, provide those three values, 1, 2, 3. And it makes this calculation, return me back those two things, 1, 2, the one I think. That's how you define functions in Python. Every program has its own way of doing coding. So this is how Python does things. I'm doing some calculation and returning the values I get, final values I get from those calculations. If you are not familiar to do it in this way, you can use your calculator. So here the theta is 45 in case C. The angle is 45, angle is 90, angle is 0. So it will be on x-axis 300 and y-axis 200. Let's go back. Let's draw it. Let's put a point, and x-axis 300, y-axis 200. So it's going to be somewhere here. Yeah, 300, 200. Perfect. Go to setting, change the name to C. That's perfect. So this is A, B, and C. Finally, I think there is a question saying where an angle or a fracture of degree 60. This was 0, 90, 45. Where a 60 will be drawn? Again, go back to the coding. Instead of 45, give it how much? Give it, let's make a text. We said it is 60-degree orientation or fall dip or fracture depth. This is a fracture rather than a fault actually. And I paste my function. I don't need to write again and again. I just call the same function and change the inputs. So the input here is 60. Let's see what it gives xy values. So x value is 200 and the y value is that much. So you see it's 0, 0, 0 because computers are not very precise in floating point operations. The the floating number, you cannot represent them very accurately. يعني you know pi is a number, it's 3.4144. There is no into it. But once you want to store it in computer, you have to cut it. You cannot go very long. That's the reason. If you then use pi in your computer, it's not the full complete pi. There are some rounding errors in computers. Those are the way, because this is the way we store things in computers. There are some workarounds, but in computation it cannot be done. The floating numbers, they are saved in computers like that. So pi is very low, 3.14, very endless number. So should I save it all? I cannot save it all. So that's the reason there are some rounding errors. Here I have the x value and y value. Let's put the random points first. Point, this is the point, and I change this one to 200. I can get them from here. I can copy this one. It's actually just 200. Let's take the 200. The x-axis here is 200. It's 200 x-axis, and the y-axis is that number you see. You can take the whole number. So here is it, and I need to change its name. uh, Angle 60, an angle of 60. That's how is it. Let's try to draw a polygon. Polygons. There's polyline, not a polygon. So polyline needs actually 3 points. I need a point in the center. I need to draw something like from here to center to there. So let's make a point. Let's first make a point in the center. We can delete it later. This is just to help draw the polyline. Polyline. Select all vertices, then vertex again. So that's first vertex. Second, finally go back to the same vertex. That's your polygon. So it's starting from A going to A, then angle 60. So we know you don't need A center. We don't need to draw anything in the center. I can say this is 300 and 0. That's the value of this point. Okay, and then I can delete. I can delete this point, point A. Um, yeah, this is a polyline with a name. I can change its color. So that's color. I can make it a. This is how much angle is that? Is 120. 60, but 120. The reason because based on the equation, you see 2 theta. That's 2 theta. So this is for part 1. I just go open in my screen capture, screen snapping tool. I have this one, this snapping tool. I think most Windows operating system they have this application. It comes by default in Windows installation. Select your working area. You can select this working area. Copy, copy, copy it. Open the document. So this is this part. We are done from first part. Nice clean figure. So I pause or stop recording. I go to the next question then.